Welcome back. We are on chapter 7, Rational Exponents, Radicals and Complex Numbers. And today we will going to work on section 7.5, Rationalizing Denominators and Numerators of Radical Expressions. Let's go to objective number 1, rationalize denominators. And many times it's helpful to rewrite a radical quotient with the radical confined to only the numerator. If we rewrite the expression so that there is no radical in the denominator, it is called rationalizing the denominator. This process involves multiplying the quotient by a form of 1 that will eliminate the radical in the denominator. And let's understand it much better by working on this example. Rationalize the denominator square root of 3 over square root of 2. So we want to get rid, we want to eliminate the radical and the denominator. What we're going to do, as the explanation was showing us, we're going to multiply by a special 1, a special form of 1. It's going to be a fraction square root of 2 over 2, right? This is 1, this is equal to 1. It keeps everything the same. But then we can rationalize because we're going to have square root of 2 times the square root of 2 and the denominator equals to 2. And the square root of 3 times square root of 2 is square root of 3 times 2, square root of 6. Now we don't have any radicals on the denominator, and this is how we rationalize the denominator. And moving on, we have a few more examples here. Now rationalize the denominator square root of 2 over 45x. And we actually can split this, right? This is going to be equal to square root of 2 over square root of 45x. We can do this, right? This is one of the properties that we have studied. And now we're going to multiply by 1. And it's going to be the fraction for square root of 45x over square root of 45x. This is 1, right? We can multiply anything by 1 and keeps the same. It's going to be the same. The denominator is going to be square root of 45x times the square root of 45x. This is the square root of 45x squared. It's just 45x. Now we don't have any square root on the denominator, and we can multiply square root of 2 times square root of 45x. We can actually put together square root of 2 times 45x. This is square root of 90 times x over 45x. Can we simplify a little bit more? I think we can, because we can factor out this 90 here. We can factor it out, and we can write this as 9 times 10, right? 9 times 10 times x over 45x. And this 9, we can actually move it outside the radical, because 9 is 3 squared. So we can move this out, and this is going to be 3, right? Square root of 9 equals 3, square root of 10x over, this is equal 45x. And we can actually also simplify, because we can divide this by 3, you can divide 45 by 3, and then you have square root of 10x over 15x. And this is the result, is the simplification and the rationalization of the denominator. Moving on, and we have another example. now rationalize the denominator of cube root of 2 over 25. Cube root of 2 over 25. The same thing we've done before, we can split. We can write this as cube root of 2 over cube root of 25. And to find a cube, a number, to simplify here, we need to find a number that's cubed, that we can simplify. 25 is 5 squared, and actually if we multiply 25 by 5, we're going to have 5 cubed, right? So what we're going to do, we're going to multiply this whole fraction here by a special 1, a fraction that is equals to 1. And this is going to be cube root of 5 on the numerator, and the denominator cube root of 5. Right? This is a special kind of 1. And we can combine this, we can multiply, right? 25, cube root of 25 multiplied by cube root of 5. This is going to be equal cube root of 125. And on top, on the numerator, we're going to have cube root of 2 times 5, cube root of 10. Cube root of 125, we know this will result, 125 is 5 cubed, so this is equals to 5, right? And on the numerator, we're going to have cube root of 10, and this is the simplification that we are trying to find. And with the denominator rationalized. And we're going to have another example here. Now we have some variables, and we have this radical expression here with a fraction, a rational expression as well. We can split 7x, square root of 7x over square root of 3y, multiplied by this special 1 here. This special 1 is going to be square root of 3y over square root of 3y. This is equals to 1. And then the numerator is going to be just 3y. We got rid of the square root, just have 3y on the denominator. And the numerator now is going to be square root, and we can multiply 7 times 3. 7 times 3, 21, right? And x times y, xy. And this is the result. This is the simplification by also rationalizing the denominator. This is the last example by now, because now we're going to work on the next objective, number 2, rationalize denominators having 2 terms. And many rational quotients have a sum or difference of terms in a denominator rather than a single radical. In that case, we need to multiply by the conjugate of the numerator or denominator, whichever one we are rationalizing. The conjugate uses the same terms, but the opposite operation. And if you didn't understand yet, let's work on the example, and I'm pretty sure you can understand. Check out this example, and we want to rationalize the denominator. The denominator is 2 plus square root of 7. And the first step, the first thing you have to do is to find out the conjugate of 2 plus square root of 7, and the conjugate is going to be 2 minus square root of 7. This is going to be the conjugate. We will multiply by 1, and the 1 is going to be this fraction here, 2 minus square root of 7 over 2 minus square root of 7. This is 1, we can multiply, not changing anything, but the result is that we're going to have, and I will do this step by step really slowly so you can understand. 2 plus square root of 7 times 2 minus square root of 7, and on the top you're going to have 3 times 2, let's do the distribution here, 3 times 2 is 6, minus 3 times square root of 7, 3 square root of 7. Oops. Okay, on the denominator, we're gonna actually remember here the special product. Do you remember this special product here? A plus B times A minus B. This is equal to A squared minus B squared. So we're going to apply this special product to simplify, because this is going to be A is going to be 2, and B is going to be square root of 7. So apply, apply here, A squared is going to be 4, 2 squared 4, minus B squared, square root of 7 squared is 7. And on the top, we're still going to have 6 minus 3 square root of 7. Simplify, actually combining like terms here on the denominator. 4 minus 7, negative 3. Negative 3. I'm going to do step by step. 6 minus 3 square root of 7. And we can simplify a little bit more, even further, because 6 divided by negative 3, 6 divided by negative 3 is negative 2. Let me write here negative 2. And negative 3 divided by negative 3 is 1. That means 1 square root of 7. Square root of 7 minus 2. This is the result. This is the simplification. Great. Let's try another example. Let's work on another example. Now we have to rationalize the denominator, and the rational expression that we have is this is a rational expression with radicals, right? It's square root of 3 plus 2 over the square root of 2 plus 3, plus the square root of 3, I mean. And we will multiply by the conjugate of the denominator. The conjugate of the denominator, we're gonna find first. The conjugate of the denominator is square root of 2 minus square root of 3. This is the conjugate of the denominator. And we're going to multiply the whole fraction by 1. And 1 is this fraction here. Square root of 2 minus square root of 3 over square root of 2 minus square root of 3. This is equal. And remember, the special product, I will write down again here so you don't forget. This is special product, A plus B times A minus B equals A squared minus B squared. Oops, this is supposed to be a 2 squared. Great. And we're going to apply this special product to simplify, because this is A, this is B, and this is going to be A squared, square root of 2 squared is 2, minus B squared, minus square root of 3 squared, minus 3. And on the top, we will have, and let's do this really slowly, step by step. Square root of 3 plus 2 times square root of 2 plus square root of 3. Okay, that's right. And combining like terms on the denominator, we will have 2 minus 3, negative 1. Negative 1, we can actually just represent the negative here in front of the expression, right? Negative 1. And let's work out the distributive property. As we will, let me just get another color here. We will distribute square root of 3 here and there, and 2 here and there. Let's apply the distributive property here. So we will have square root of 3 times square root of 2, square root of 6. 3 times 2, 6. Square root of 3 times square root of 3 is going to be, and this whole thing is negative. This whole thing is negative. Square root of 3 times square root of 3 is 3 squared. Square root of 3 squared is 3. 2 times square root of 2 is 2 square root of 2. And 2 times the square root of 3 is 2 square root of 3. And very good. Now that's it. That we can simplify. That's it. I don't see any more simplification that we can do. Actually can rewrite just removing the parentheses. The only thing that we might do here is remove the parentheses. Negative 6 minus, and there's something, oh, no, there's something wrong here. Let's fix this. This is negative here, negative. So we're gonna have this one is going to be negative. Right, negative. Then we're going to have negative square root of 6 minus 3 minus 2 square root of 2 plus 2 square root of 3. Yeah, don't be careful with the signs, because this is what usually leads to most of the mistakes, just a small sign. Great! That's it. This is the simplification that we're looking for by rationalizing the denominator of this rational expression with radicals. Moving on, and now we have the next objective, which is objective number 3, rationalizing numerators. The usual thing is to rationalize the denominator, but eventually you might be asked to rationalize the numerator. An expression rewritten with no radical in the numerator is called rationalizing the numerator. And let's get an example here. And it's going to be the same thing, but instead of working on the denominator, now we're going to work on the numerator. And we can split this as 12 over square root of 12 over square root of 7. And we're going to multiply by a fraction that is equivalent to 1, square root of 12 over square root of 12. And then we have square root of 12 times square root of 12 is just 12. You don't have any radicals anymore on the numerator. And the square root of 7 times 12 is going to be square root of 84. You can simplify a little bit further, because you know that 84 you can actually factor out. So let's repeat here the numerator. 84 is 4 times 21. Oops, 4 times 20. Let me erase this. 4 times 21. And we can move this outside, because 4 is 2 squared, and we will have 12 divided by 2 square root of 21, which is 6 over square root of 21. But this is the simplification by rationalizing the numerator. Now we are rationalizing the numerator. Another example. Now rationalize this numerator here, and the same thing we're going to do, the same step by step. Just first you're going to split cube root of 9y over cube root of 7. And we are looking now at the numerator. We are looking at rationalizing the numerator. So let's multiply. And the 9 is 3 squares. And if we multiply here by 3, we're going to have 3 cubed. And y is just y exponent 1. We can multiply by y squared. Oops. Y squared. And then we will be able to simplify the cube root here, this cube root. So let's multiply the whole fraction by this fraction equivalent to 1. 3y squared. So cube root of 3y squared over cube root of 3y squared. This is a fraction that's equivalent to 1. We can multiply here without changing anything, but we actually gonna rationalize. We're gonna be able to simplify the numerator. So multiply 9 times 3. 9 times 3 is 27. Y times y squared is y cubed, and this is the cube root, right? Cube root over, and here on the bottom we're going to have cube root of 7 times 3 y squared. 7 times 3, 21 y squared. On the numerator, we're going to be able to take this off the radical, right? Because 27 is 3 cubed, and we're going to be able to take this off the radical as well, because this is going to be y cubed. The cube root of y cubed is just y. And as a result, we will have 3 times y over cube root of 21 y squared. Oops. Y squared. Okay. This is the result. The simplification by rationalizing the numerator. Next and final, the last example that we have for today is this: rationalize the numerator. The numerator, and the same thing we've done before with the denominator. Now we have to find the conjugate of the numerator, and the conjugate of this numerator here is going to be square root of x minus the square root of y. This is the conjugate of the numerator. So multiply. On top, multiply by square root of x. Oops. Square root of x. This is the conjugate minus square root of y. On the bottom, the same thing. So we have a fraction that's equivalent to 1 minus square root of y. See, we're multiplying by 1. We're not changing anything. But when we multiply, we are able to simplify. We rationalize the numerator. I will write down again, so we don't forget, we are using this special product, a plus b times a minus b equals a squared minus b squared. Okay, this is the special product that I'm applying here, and this is going to be a, and this b. So let's write down here. Square root of x is x minus the square root of the square of square root of y, right? So square of x, square root of x, x minus square root of y squared, y over, okay, over. And on the bottom, check it out. We have this is going to be a square, x minus square root of y squared. And there's another special product that we can use here that can help us simplify this. And let me write down here. Let me just erase this special product we have used already. And let me write down the other special product that we are going to use is this one in green. Let me write down a plus b squared equals a squared plus 2ab plus b squared. Right? We can apply this on the denominator because we're going to be able to simplify a little bit the denominator as well. Check it out. So we will apply here on the denominator. This is equal. Square root of x is squared equals x minus 2 times, and this is going to be a, I'm using green now. This is a and this is b. Okay, I'm using green on this new special product. Okay, so 2 times a is square root of x, sorry, square root of x, times b, square root of y, and then we can put this together, plus the square of square root of y is y. That's it. And on the top, we will have x minus y. And that's it. I don't think we can simplify a little bit more. That's the best we can do. That's the best simplification we can find. This is the result of that original rational expression here that we are working with radicals as well by rationalizing the numerator. And this is the end of section 7.5. Thank you for watching. See you next time.